So this is our 10th session on coordinate geometry. Okay, so we have done with almost all the important areas, and last session we were discussing about straight lines. Okay, we discussed about conditions of like parallel lines. We have seen family of parallel lines. We have seen family of perpendicular lines. Then we have discussed about transformation of axis, and then we have discussed about rotation of axis. Okay, now in this session we are going to start with circle, and I'll try to complete it with circles. Maybe one more session I'll take. Okay, so here I am going to start with circle. What is circle? You can clearly see, let's suppose I have a fixed point here. Okay, so let me mark this point as C, H, comma, K. This is my point, fixed point. Now I am taking a moving point, okay, on a particular distance. I'm taking a moving point, let's say P of X, comma, Y. So C is my fixed point and P is my moving point. So you can try with a toy also. You can keep a fixed point and this moving point can move, okay, by keeping a fixed distance. So what I'm saying is this is a fixed distance, which is, so this moving point can move like this from this fixed point at a fixed distance. Okay, now if you trace this path in which this moving point is moving, what you will get is a circle. So circle is nothing but locus of a point. Okay, locus of a point which is moving such that the distance from the fixed point and the moving point is constant. So the locus of a point which is moving in such a way that the distance from the center, that is a fixed point, is constant. And this fixed point is what we call as a center. So here C of H, comma, K is my center. Then what is my radius? Radius is the fixed distance. Okay, so radius is the fixed distance, and this is a moving point. P of xy is the moving point. So that's what your circle. Now let's try to understand the equation of a circle. Okay, so what you can do is you can take a circle with the same center C as H, comma, K. Okay, so that's your center, and let me take a moving point anywhere on the circle. So moving point means it can be anywhere on the circle. So I'll mention it as X, comma, Y. That means X and Y can take off any values. So if I put a particular value, I may get the point here. If I put another value for X and Y, I may get another point here. But every point will be on the circle because it is keeping a fixed distance R. Okay, so then how will you get this distance? See, I've given you these 2 points. So C of H, comma, K, that is at the center, and I'm giving you this point P of X, comma, Y. Can you get this distance? That distance is what we call as R. R, can you get this distance? If you remember, we can apply distance formula here. If you take this out, if you write like this is your H, comma, K, and this is your X, comma, Y, right? So you can apply a distance formula here. What is that? X minus H square plus Y minus K square. You take root of it, you will get this distance. And this distance is nothing but your radius, right? Because this distance is from the center to the moving point, and moving point will always be in a circle. So whether you take the moving point here, or you take it here, or you take it here, or you take it here, everywhere you are going to get the same R. But X and Y can vary. Okay, so this is how you can apply distance formula and you'll get this, right? So X minus H square plus Y minus K square, if you take under root of it, you'll get the radius. That's the distance formula. Now what you can do is you can square both sides. So you can remove this under root. So X minus H whole square plus Y minus K whole square equal to R square, and this is your equation of a circle. Okay, so the required standard equation of the circle with H and K as center and R as radius. Okay, so what you can do is you'll change the values and you'll get different equations. That's what generally happening, right? So X minus H whole square plus Y minus K whole square equal to R square, where H and K are the centers. So H, comma, K will give you the center and R will give you the radius. So this is the standard equation of a circle. So center is given and any point on the circle is given, that is X and Y. This is how you'll get the equation of the circle. Okay, now let's try to understand some particular cases. So if the circle having center at origin, so let me draw a circle like this in my Euclidean plane. I am drawing a circle like this with my center as origin. So this is going to be 0, 0, and your point can be anywhere, right? And this distance will definitely give you a radius. So this point is your X, comma, Y. So in this case, what will be the equation of a circle? See, general equation we understood, that is X minus H square plus Y minus K square will give you radius square, right? Now here we clearly know h equal to 0 and y equal to 0. So what you can do is x minus 0 square plus y minus 0 square equal to r square, which will give you x square plus y square equal to r square. What is this? So x square plus y square equal to r square is the equation of a circle which is having center at the origin. Or you can just apply distance formula and you can get this, right? How will you apply this? X minus 0 square plus y minus 0 square, if you take under root you will get r. When you square both sides, x minus 0 square plus y minus 0 square will be r square, x square plus y square will be r square. So this is the equation of a circle having center at origin. Okay, so that's your special case, case one. Now next case that I need to discuss is equation of a circle which is passing through origin. So I hope you understood the difference. Here the center is at origin. That means none of the part of the circle is touching the origin. See, this part is outside the origin, center is in the origin. But here what I'm saying is the circle passed through origin. That means one of the part is going to touch the origin, right? So if you can visualize, it will be like this. I can draw like this. So this is your circle. So you can clearly see the circle is touching the origin, right? So center will be somewhere here, and that's your h comma k. Okay, C is the center, that is h comma k. Now here, what is the radius? This will be your radius, right? And because this is the distance from the center to the moving point, similarly this will also be your radius only, right? This will be your radius. So if this is O and if this is C, OC is actually your radius. Now what you can do is you can drop a perpendicular here. So if you mark this point as K, okay. Now, can you find the equation of this circle? See, what is given is, you have been given h, you have been given k, okay? So, now r square, so general formula is x minus h square plus y minus k square equal to r square. Now the question is, see, this x in the center x coordinate is k. What does that mean? This distance is going to be h, right? So x coordinate is h, so this distance is going to be h. Now y coordinate is k, that means this distance is going to be k. So if you consider now this right angle triangle, the small right angle triangle like CKO, that right angle triangle, you can see this side is k and this side is h. And can you write r in terms of h and k? That is the question, right? Because r is the hypotenuse here, because the right angle you can see here, right? This is the right angle. So r is the hypotenuse. So r is equal to, so clearly you can write r equal to h square plus k square, right? Or root of h square plus k square. When you take squaring both sides, r square equal to h square plus k square. So this r square, what you can do, you can replace it with h square plus k square. Let's see how you're going to get this answer now. What you can do is, in the next step, I'm going to do two things together. I will open up this bracket. Okay, I will change r square as this. So let's see how you're going to proceed. You'll get x square plus h square minus 2hx, right? Plus, let's open the next bracket, y square plus k square minus 2ky, right? Equal to h square plus k square. Okay, so x minus h all square is this, y minus k all square is this, r square is this. Now you can see this h square and this h square is getting cancelled out. This k square and this k square is getting cancelled out. What you are left out is x square plus y square minus 2hx plus 2ky equal to 0. So this is the equation of a circle which passed through origin. Okay, circle which passed through origin. This is how you need to interpret. So without radius also you can write that. What is just by using h and k, provided they are saying that this is passing through origin, you don't want to write r. Okay, so I hope you understood the difference. In the previous case, I need h and k, I need radius also. Here, even without knowing radius, I can write like this. So here you need only 2 points, that is the center. Provided circle is passing through the origin and you know the center, you can write the equation of the circle. So this is the equation of the circle which passed through center, which passed through origin. Okay, now let's move on to the next case. Now I'm looking for the equation of a circle which is touching the x-axis. So what do you mean by touching the x-axis? So when I say touching the x-axis, this is my x-axis and this is my y-axis. Can I talk of this circle? No. This is not touching the x-axis, this is cutting x-axis at 2 points. Okay. Similarly, can I take this circle? No. This is not touching x-axis, right? So I'm going to take this circle where the circle is touching the x-axis, means x-axis is actually acting as the tangent to the circle. Okay, so that is another way in which you can interpret, and that's how you'll get the question. X-axis is actually tangent to the circle. Also, you will be given the center. Okay, that is h comma k, that is a sender. Okay, so that's your C. Now if x-axis is a tangent, now can you tell me what is this distance? This distance is clearly h. Okay, and what is this distance? This distance is clearly your radius, because this is your sender. So k is equal to r here, right? So here k is equal to r, and that's how you need to understand here. Why k is equal to r? Because you can see this distance is nothing but your radius. This is circle touching x-axis and this is a sender. So from the sender to the x-axis, the distance is actually your radius only, and that is your y coordinate, right? That is your k. So k equal to r. Now if you substitute in the general equation, x minus h whole square plus y minus k whole square equal to r square, what I need to do now? I need to substitute k equal to r. Okay, so let me do that. X minus h whole square plus y minus r whole square equal to r square. Now I will open up the bracket. Okay, so x square plus h square minus 2hx plus y square plus r square minus 2ry equal to r square. Now r square and r square is getting cancelled out. What you will be getting is x square plus h square minus 2hx plus y square minus 2yr is the required equation. So this is the equation of the circle which pass through the x-axis, not pass through the touching the x-axis. So we are looking at different types of circles, okay, in the Euclidean plane. So first we have seen random general equation where center and the radius is given x minus h square plus y minus k whole square will give you r square. Then we have seen it as center as origin, then x square plus y square equal to r square. Then we have seen the circle pass through the origin, there we don't want any r, right? Then here we have seen circle touching x-axis. So obviously what will be the next one? Circle is going to touch the y-axis. Okay, so circle touching y-axis means I can't take this case because it is cutting y-axis, right? I can't take this case because it is not touching y-axis. So which case I will be taking? I will be taking this case where h comma k is my center, okay, and circle is touching the y-axis. So this is where the circle is touching y-axis. So clearly this is your radius, and that is nothing but your x coordinate. So your x is equal to r, that is h, right? Here this distance, this is your h, and you can clearly see h is actually equal to r. So h is equal to r. Like in the previous case, k was r, there the y coordinate was the radius, here the x coordinate become the radius, right? So in your general equation, x minus h square plus y minus k whole square equal to r square, what you can do now, you can substitute h is equal to r. Now you put h is equal to r, so x minus r square plus y minus k square equal to r square. Now if you open up the bracket, x square plus r square minus 2xr plus y square plus k square minus 2ky equal to r square. So which one will get cancelled out? You'll get this r square and r square is getting cancelled out. So x square plus y square minus 2xr plus k square minus 2ky, okay, equal to 0. So this is the equation of a circle which is touching y-axis. So I hope you understood these 5 cases: general equation, center as origin, passing through origin, touching x-axis, touching y-axis. One more case, it is going to touch both x-axis and y-axis. That means I'm not going to talk about this circle. This is cutting x-axis and y-axis, right? So here you can see cutting x-axis at 2 points and cutting y-axis at 2 points. I'm not going to talk about this. I'm also not going to talk about this case. This is not touching, not cutting. Okay, I'm going to talk of I'm not going to talk of this. This is touching y-axis only. I'm not going to talk of this. This is touching x-axis only. So I'm actually interested in this one, touching x-axis and then y-axis, both. Okay, so if your center is your h comma k, you can clearly see this is your radius, right? So, and this is your radius. So your x coordinate and y coordinate is nothing but your radius. So this is your h, which is your r, and this is your k, that is your r. So h is equal to r here, y is equal to r here. So if h is equal to r and y is equal to r, what you can do is x minus h whole square plus y minus k whole square equal to r square. You can just substitute x minus r square plus y minus r square equal to r square. Now when you open up the bracket, x square plus r square minus 2xr plus y square plus r square minus 2yr equal to r square. Now here r square is getting cancelled out. Then what is left out? X square plus y square plus r square minus 2xr minus 2yr. That's your which is equal to 0. That's the equation of a circle which is touching x-axis and y-axis. Okay. Now finally, next case what I need to see is if you remember in the third case that we have discussed is passing through origin, right? Now what I'm going to say is the circle is going to pass through origin, but the center of the circle is on the x-axis. So it will go like this. The circle is going to pass through origin like this, and the center is here on the x-axis. So circle is passing through the origin clearly, and the center is at the x-axis. That means this distance is clearly your r. No need to have any doubt, right? That's your radius. Okay. So this point is now going to be r comma 0 because y coordinate is 0 on the x-axis, y equal to 0 on the x-axis, right? So x minus h whole square plus y minus k whole square equal to r square will become, what is your h? H is your r, right? So x minus r whole square plus y minus k is 0, right? So y square equal to r square. Now you can open up this bracket, x square plus r square minus 2xr plus y square equal to r square, and this r square and this r square is getting cancelled out. So what you'll get, x square plus y square minus 2xr equal to 0. So this is the equation of a circle which is passing through origin and center at x-axis. So if you remember, we have discussed a case where the circle is passing through x-axis. That is general, but we were not discussed about where was the center. Center was randomly given as h comma k at that time. Here I am specifically saying it is on the x-axis. So your x coordinate will be the radius clearly, because it is passing through origin. So this is the only possibility, right? And the center is at the origin means this distance has to be r. So the center having x coordinate is your radius and y coordinate is 0 because on the x-axis y equal to 0. If I can find the equation of a circle in this case, why can't I find the equation of a circle which is passing through origin and center at y-axis? So I can put it in this way, right? The circle will be like this. It will pass through origin and I will have center at y-axis, right? This is how the circle will go. So if you draw it properly, it will be like this. So center at origin, no, center on y-axis. So center on y-axis means x is going to be 0 and y-axis, y coordinate will be r, because this distance is your radius only. This is your center and this is the extremity, one of the extremity of the circle or one of the point on the circle. So center to the point on the circle, the distance is your radius. So this is clearly your r. So you can write your k equal to r and your h equal to 0. So in your equation, x minus h whole square plus y minus k whole square equal to r square, substitute k equal to r. So x minus 0 square plus y minus r square equal to r square. Eventually you will get x square plus, open up the bracket, y square plus r square minus 2yr equal to r square, and this r square and r square is getting cancelled out. X square plus y square minus 2yr equal to 0. You can compare these two equations. So here x square y square, so here x square y square, here minus 2yr, here minus 2xr. So if it is touching, if the center is on the x-axis, minus 2xr. If the center is on the y-axis, minus 2yr. So I hope you understood. This is the two cases where the circle passed through the origin. Now, in the first case, when we discussed about circle just passing through origin means it can be like general case, right? So here you can see circle is passing through origin. And the equation of this circle we have seen, x square plus y square minus 2hx minus 2ky equal to 0. Okay, so this is a general case. Now, in the very same equation, okay, so you can see here x becomes r and y becomes 0. So when you put x is equal to, no, this h is equal to r, right, and y equal to 0, what you will get? X square plus y square minus 2rx equal to 0. That is this case. Similarly, h is equal to 0 and k equal to r, what you will get? X square plus y square minus 2 ry equal to 0. So if this is this equation, this is this equation, right? So from here also you can get the answer just substituting. See, the moment you understood this, see, this case you understood, this is your equation, right? And now you can write these two as special case of this one, right? Because this is what actually happening, right? Passing through center, and this is the origin. So you got y coordinate as 0, okay, and x coordinate as r. So just substitute h is equal to r, k equal to 0. You get this? Similarly, when you talk of this case, you just substitute this y coordinate as r. So this is r and this is 0. You'll get this equation. So once you know this, these two are actually special cases, right? So I hope you understood all the cases that we have discussed. We started off with general equation of a circle, x minus h whole square plus y minus k whole square equal to r square, where h comma k as your center and r is your radius. So this is a general case. Then the second case that we have discussed is the equation having center at origin. If center at origin means this h is going to be 0, k is going to be 0. So what you'll get? X square plus y square equal to r square. That was your second case. Third case, what we have seen, the circle passing through origin. That means x square plus y square minus 2hx minus 2ky equal to 0. In that we have seen two sub cases. The first case is center at x-axis. Center at x-axis means h is equal to r and k equal to 0. What is the answer then? X square plus y square minus 2xr equal to 0. And again the circle passing through origin, center at y-axis, then this h is going to be 0 and k is going to be r. So what you are going to get? X square plus y square minus 2 yr equal to 0. So okay, I hope you understood that this is a general case. This is a second case, the center is at the x-axis. This is a third case where the center is at the y-axis. Okay, so these two are sub-case. You can write it as 4 and 5 anyway, because we have seen 5 forms. Then one more form that we have seen is the equation of a circle which is touching the x-axis like this. Just touching the x-axis, right? So what was the expression there? X square plus h square minus 2xh plus y square minus 2yr equal to 0, right? Then we have seen the case of touching the y-axis, right? So not cutting, touching the y-axis. So there we got the equation as x square plus y square minus 2xr, here 2yr. So this is the change, plus this instead of h square, this is k square, right? Then plus instead of xh 2ky equal to 0. So the changes you can see here, h square, see here, this 2xh is 2ky, 2yr, 2xr, h square, k square. That will change, okay? Last case that we have seen is it is touching both xy axis. Okay, draw it properly. Touching both xy axis. So your answer is x square plus r square minus or plus y square minus 2xr minus 2yr equal to 0. So these are the 8 cases that we have discussed, and you need to keep this in mind. You can directly get this during exam time also, but it is always better if you can remember, it is better. Okay, so first one is the general equation with center h comma k, x minus h square plus y minus k square is equal to r square. This is the equation of the circle which is having center at origin like this. Center is at origin. Third case, equation of circle which is passing through origin. Fourth case was a subcase of this only, passing through origin and center at x-axis. Fifth case is passing through origin and center at y-axis. Sixth case is touching x-axis. Seventh is touching y-axis. Eighth is touching x and y-axis. Okay, so these are the cases that we need to remember. So I'll discuss other forms of circle and other important concepts in the next session. So if you have any doubt, get back to me. Okay, so this is my number. So I hope you understood the session. So see you guys. Thank you.